Hi, in this video I'm gonna be solving exercise 10, number 9 and 10. Okay, let's continue. So first I'm gonna be using these formulas. If you don't know, you can pause and learn this. And then I'm gonna be using small o properties. Okay, next page. So let's start. Oh, before we start, I want you to subscribe. And you already know why. First one, it gives me encouragement, happiness to make more videos for you. Next, I'll be uploading more videos before midterms and finals each semester, so you want to stay updated. Thank you. Hashtag I love Epita. Next. Okay, in this problem number 9, we have this, and again, still we don't know how to. By the way, I'm not using my earphones now. Till now I was using my earphones to record the voice. I'm just recording the videos using my phone now, so we'll see how it goes. No earphones in this video. So we have this, and then so do we know until which order to expand? No. So we go with first order, and then see what happens. But I give you clue in this video, very important clue. So always whenever you have expression, you try to search for multiplication. If you have multiplication, it's usually based on that. But if you don't have multiplication, you go with first order and then second order and then third order, and it depends. But in this case we have multiplication, which is we have n square and we have root. Instead of root, let's write 1 over n plus 1 ln 1 plus 1 over n square to the 1 over 2, because it's the same thing, minus 1. So in this case I have n square. Do we have multiplication? Yes. And it's here, and because I have n square, like in this bracket, in my mind, like this is something that's going on in my. Oh wait, I'm having so many notifications, I forgot to mute my phone. So in here I want to have n square, like inside something plus o to the 1 over n square, because when I multiply, open the bracket, I'm going to have O1, and this is what I'm looking for in exercise 10. So that's the reason why from here I need to go with the second order, and this is the first clue. This is clue number 1. Clue number 1, it's L. Clue number 1 is here. Clue number 2, very, very important. Whenever you say this is U, let's say this is U. I'm using this one. This is U. You must mention U tends to 0. It's important. You must know this. I mean, actually it must be X, but in the place of X in the formula you have 1 over n square. And right now, if you say that X is equal to 1 over n square and it tends to 0, why? Because n goes to infinity. If n goes to infinity, this 1 over n square goes to 0. And it means that you can use the formula. So mentioning U tends to 0 is important. If they strictly check this on your finals, they might give you penalty points like minus something, minus 1 or minus 0.5. Okay, now in this case, you have, where's my marker? N square and 1. And if you go with the second order for ln, it's equal to 1 over n square minus 1 over 2 times 1 over n square plus o n square. It's o 1 over n square minus 1. Okay, and then we continue. N square. Oh, I forgot something here. What is it? This 1 over 2. Okay, and now the thing is, because I have 1 over o n square, I'm looking for the second order. It's gonna be 1 over n to the 4. So I don't need it, so I don't have to write it, so I have this one at the end. 1 over 2 minus 1. Okay, now in this case you can use like e this is equal to e to the 1 over 2 times ln this. But instead, if you memorize this formula, I'm gonna show you right now. Look, formula number 7. Right now, I'm gonna be using formula number 7. 1 plus x to the a. 1 plus from here to here, it's x, which is u. This is, and u tends to 0. So I can use the formula. So it's equal to according to formula number 7, n square. So 1 comes here, so 1 over 2 1 over n square. I'm just going with the first order. Okay, yes, and 1 over n square, and I have minus 1 here. Okay, next, from here you go to, if you go to second order, from here to here you go to second order, but like because you have 1 over n square already, you only need this one. I mean, the same thing from here to here, the same thing happens. This is equal to this one, and 1 cancelled. So you have, if you open the bracket right now, n square times n square, this is square, this is square, it's gonna be 1 over 2 plus 1. So this is equal to 1 over 2. Okay, now next, exercise 10, number 10. Okay, let's continue. In this case, let's take this expression, n over n minus 1 to the n minus, no, plus e. So this one, you can write this as reciprocal of this one is equal to n minus 1 divided by n to the minus n plus. This one is equal to 1 minus 1 over n to the minus n plus e. You can write this one as e to the minus n ln 1 minus 1 over n plus e. And here you say this is u and tends to 0. Okay, u tends to 0. And you go with the first order because why you go with the first order? Because you have multiplication and it's n times, in my mind you have n times something something plus 1 over n. This is gonna give you something something plus 1, and this is what you're looking for. That's the reason why first order from here. So e to the minus n, e to the minus n, and then what? Minus 1 over n plus 1 over n, this plus e. So if you open the parentheses, it's gonna be e to the 1 plus 1 plus e. So then limit n approaches infinity. Why u tends to infinity? Because n approaches infinity. Limit n approaches infinity. What is it? I'm calculating this one right now. n minus 1 n plus e is equal to e1 plus e, which is 2e. So limit of ln and this limit of ln, because you have ln, it tends to ln 2e. You can stop right here, but you can continue a bit. This is equal to ln 2 plus ln e, and this is equal to 1, ln e plus 1. I recommend you to calculate until here, but if you're not sure from here how to go here, then just stop here. Final answer is this, or it can be this. Okay, that's it. Bye bye.